Hey everyone, so I am going to create a video for you all to read, interpret, and make your own station plot. So there's so much information that we can get from one little itty bitty thing, and I'm going to break it down for you step by step and show you how you would draw your own, which you are going to, by the way, and we will go from there. Okay, so here, this PDF will be available for you, by the way. So this is what we call a station plot. And there's a lot of things going on here, but I'm just going to try and break it down for you step by step. So we have numbers here on the left-hand side. We have a number on the top, which gives us temperature, and a number on the bottom, which gives us dew point temperature. And we'll really break those things down, at least dew point temperature. We'll break that one down in the next week or so. But just know that it is the dew point temperature. In this particular example, it is given in degrees Celsius. Everything that we're going to work through is going to be in degrees Fahrenheit. So just keep that one in mind. And then notice there's this little symbol here between these two numbers. That's significant weather. So that can be anything from wind, rain, or sorry, not wind, rain, snow, haze, fire, all that kind of stuff, thunderstorms. And I will kind of break down exactly which and what of those things there are. There's different symbols for them. Here, this little barb here is what we call a wind barb, and this gives us wind speed and direction, gives us both. And these little prangs here, for lack of a better word, give us the wind speed, and then where the barb is pointing towards is where the wind is coming from. So it's going to be a little bit confusing, but in this particular example, the wind would be coming from the northeast. And then you see this little number here on the right-hand side. This is telling us atmospheric pressure. Unfortunately, we got to decode the pressure part. It's not just straight up 987. Not a very feasible number, but don't worry, I'll show you how to break that one all down. And then this circle here, how much that is filled in gives us cloud cover. So in this particular example, it's completely filled in, so that just means that it is a completely cloudy day. So let's break this stuff down a little bit further. So just to kind of break down the cloudiness aspect of it. So that little circle in the center, again, however much it is filled in tells us how much of the sky is obscured. As a mathematician or someone who loves math, this really bothers me. If it bothers you, it bothers me too. 4/8, break that sucker down to 1/2. I didn't write the textbook, it's just there. But so it's basically if you were to look up at the sky and ask yourself how much of the sky is obscured with clouds, it would either be partly cloudy in terms of like only a quarter of the sky, half of the sky, or fully overcast. This X here just means that the sky is obscured. So that is essentially the instrument just can't see what's going on. There might be a tree or debris in the way or some things there. We just can't see what the cloud covers, what's happening with the cloud cover. Next up, we have what is going on in the current weather sort of status, right? So in the first example, it had 2 dots, which just meant light rain. And that one's pretty straightforward. And then it's kind of cool because we go from rain to snow, and the snow part is just little asterisks, so that, you know, a snowflake kind of looks like an asterisk, right? So that makes sense. And then there is a difference between a snow shower and a rain shower and just overall rain. I know we don't really get it too much in the Bay Area, but if you were just to have a little itty bitty like rain shaft, that would be what we consider a rain shower. Then over here we have thunderstorms. I know another thing we don't really get too much here in the Bay Area, but the look of that looks very much like what we'll learn to be a cumulonimbus cloud, but this little arrow here looks like a lightning bolt. So it's a nice little boop, boop, boop looking thing there. And then if it's a severe thunderstorm, we don't have 1 kinks, we got 2 kinks. We get real kinky up in here. And then we have freezing rain. Terrifying phenomenon. Again, not something we really see here in the Bay Area, but you may see it on a station plot. We also have fog. that just looks like lines. And that makes sense, right? Because here in the Bay Area, we get that sucks all the time. So, looks like layers of blankets almost, right? And we see that one all the time. We also see haze quite a bit in this area as well. Okay, moving on, we have wind speed. So remember when I said that that little barb had little prongs on it, and those prongs help indicate wind speed. So if that little half guy, that means 5 knots. Then if we have a full barb, that means 10 knots. And then if you have multiples of those on one wind barb, you just add those suckers together. So up until we get to 45 knots. So see how this one here has 4 long prongs and 1 half prong. 10 plus 10 plus 10 plus 10, that's 40 plus 5, 45. But if we were to continue that way, that's going to be like way too much, right? Because we do have wind speeds over 45 knots quite often. Maybe not so much in the lower atmosphere, but when we get up above our heads, it does indeed do so. So what we do is we give it a little flag, and that flag denotes 50 knots. And then the same procedure there. So if you have a flag plus a long barb, that's 50 plus 10, you got 60 knots. And again, that procedure just continues on until you have to once again reach another 50 knots. So then you would have 2 flags, which is 100 knots. And remember, knots are very, very similar to miles per hour. Knots just means nautical miles per hour. So like 50 knots would be like, like 45 miles per hour, something like that. Okay, and I gotta include that it's not just, it's not a very specific, like that one little barb there is exactly 5 knots. Just for completeness purposes, it is a range. So have a look at this just for completeness purposes. Next up, and this is the big one, is pressure. So the 3 numbers that are given to you, I'm going to scroll back up here to the first thing. These 3 numbers right here that are given, that's not the exact pressure. You got to decode it a little bit. So if you look at that number and the first digit, so the first digit would be this cute little guy right here. In this case, it's a 9. So that little number there will help us indicate if we're going to add either a 10 or a 9. So because it was a 9, then we would add a 9 to the front, and then we would add a decimal in between the last 2 digits. So again, if your first digit is a 0 or a 4, then you would add a 10. But if the first digit is a 6 or a 9, then you add a 9, and then you always got to add that sweet little decimal there. And then a good rule of thumb is the accepted range of pressures is between 960 and 1040 millibars. So if the pressure that you decode happens to be out of that range, then maybe you got to rethink this one. So I'm going to go back here to, hi, me webcam. So if I were to give you, or if the pressure that's on there is indicated to be, say, 389, so 389, what I would do is I would look at my first digit, boop, 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 3, right? And that is between 0 and 4, right? So because of that, then my 389 turns into 10,389. That's a big freaking number, right? Is that right? Nope, because it's out of our range. So remember, we have to add our decimal. Big ol' thing we gotta do there. We added our decimal. Now we know that our decoded pressure is 1,038.9 millibars. So we're gonna get a ton of practice with this in the lab for this week. So don't freak out if you're like, what the heck did you just say? You can always rewatch this video. You can always ask me questions, and I will go over this concept again in lab, but this is now available for you on the side, so you can always check that out. Let me know if you have any questions.